All right. So, see if I can do this nicely. So this is for my 30-degree reference angle, agree? Good. You guys responded. Yesterday they sat there going, oh, I don't know. Just kidding. That's my 45. And my last one. That's basically for my 60. Okay? So as you go around the unit circle, this is 0 and 360 degrees. This is the point, or we won't even do the point yet. So this is also going to be 0 and 2 pi as far as the radian measure goes. Then I have 30 degrees here, 45 degrees here, 60 degrees here, 90 degrees here, and I'll take care of the radian measures in a second. 120 degrees, 100 and, oh my gosh, I just had a total brain fart. 135, thank you. 150, 180, 210, 225, 240, 270. Let's see, that's 300, 315, 315, and 330. Does that look right? Okay, so let's put in our radian amounts. So I'm good with this being pi over 6. I'm good with this being pi over 4. I'm good with this being pi over 3. This good with pi over 2. Agree? All right, help me out. What's 120 as a radian? How much? 2 pi over 3? Thanks. What's 135? You guys are so cool. What's 150? Yay. I'll take care of this one. That's just pi. What's 210? 7 pi over 6. 225? 240? 4 pi over 3. 3 pi over 2. 300 is 5 pi over 3. 315. And 11 pi over 6. Cool. Everyone feel comfortable with those? If you got stuck on it, you just need, I mean, I think the 30 and 45 and 60, you have to know how to do those. If you get stuck on the radian ones, multiply by pi over 180, and it'll take care to reduce the fraction, obviously leaving this pi. And then let's take care of our points. So this is the point 1, 0. This is the point up here, 0, 1. This is the point -1, 0. This is the point 0, -1. Good so far? All right. And then on the 30 degree, being it's a 30-degree angle, that means your long side is your x component. So that's going to be root 3 over 2. Your short side will be in the vertical component. The pi over 4, that's going to be root 2 over 2, comma root 2 over 2. This one is going to be the 60 degrees. So your short side is the x component. Your long is the y component. You got 0, 1. And if you know that, then you can go all the way around the circle. So that's going to be -1/2, root 3 over 2. I don't know why I put that over 3. I'm sorry. This one is going to be the negative root 2, comma, root 2 over 2. This one is our 30 degrees, so we're going to have our long side in the x direction, so negative root 3 over 2, comma 1/2. Got that one. Both are going to be negative here, so that's my 30, so I get negative root 3 over 2, negative 1/2. Both are negative here, negative root 2 over 2, comma, negative root 2 over 2. Down here, we're going to get the x component will be my shorter value. Y value is the longer. Got that. My x component will be the shorter. My y component will be the longer, but it's negative. They're the same here, but I have a negative in the y direction. And this one here is the x component is the longer. The y component is the shorter, and it's also negative. Okay, so if you feel good about that, okay, and again, it goes with the short and long side. You're just understanding. It's called the Hinge Theorem in geometry. It's not always taught, but if you have a small angle that opens, the side opposite of that would be small. If it's a big angle that opens, then it'll be bigger. Let's see. Down at the bottom it said, what does the x coordinate represent? Cosine. What does the y component represent? Sine. What is the tangent, or what is the what does the slope represent? And it's tangent, right? So, and the reason why you know tangent is y over x, because the change in y over change of x is a slope equation. So you go with that. Okay? So keep this in a safe place. This can be used on our quiz that we have on Wednesday. Okay? What I would do, if you have a nice, neat looking page, being that I know sometimes you forget to bring paper back, but there's something I know y'all don't ever forget. Why don't you take a picture of it real quick, put it on your phone. If that's the only thing open on your phone on that day, that'll be the only quiz I'll let you use your phone on. Sound good? And then keep that page open. We're going to start the notes on sine. We'll start the notes on sine. I'm not going to get done, so I'm not going to really be able to assign, a lot of homework other than to start sine, but we'll finish it. But I hope to get this with kind of an understanding. I don't know if I like this seat because I echo. Shoot. Just can't have nice things. I was going to go take the yellow chair, but I know it's going to fall apart on me, and then you guys will point and laugh. And don't get me wrong, it'd be funny. Am I in your line of sight of the board? Okay, I just want to make sure. Dude, I can move it this way to get in your way. Going, oh, come on. All right, let me go back to the beginning of our notes. So keep that unit circle out, because this is going to totally help you when we start getting through this. So what we're aiming towards with these problems is we're going to graph the sine function. We're going to develop an understanding. When we start graphing the sine function, what we want to do, we're going to get rid of the unit circle and just keep the xy axis. So the xy axis in the x direction is going to go from 0 to 360 or 0 to 2 pi. Now, I don't want you to go and make a really long line and try and count out 360 tick marks. Okay, that'd be too much. Being our radius on our unit circle is 1, so I can get to a point of 1, 0 and a point of negative 1, 0. So the y direction we will go on this is between positive 1 and negative 1 unless it starts shifting, but we'll see what happens with that. All right, so this is our most basic parent functions. So what values do you need on the x-axis? Well, you need basically 0, 90 degrees, 180 degrees, 270 degrees, and 360 degrees, which is back to 0, which is 0, pi halves, pi, 3 pi over 2, or 2 pi, depending upon what you want. Now, I know this has happened to you at some point. You look down and let's say you don't have the fancy calculator, but you have the old cheap one. And let's say you're sitting in a science class and you look down, you get done with the test, and you're just like, oh, it says rad on it. It's not because it's cool, it was in radian. Well, degree in radian doesn't really make any difference until you start dealing with trig. All of the math operations, for the most part, should work if it's in degree or radian, just the exact same. If you are doing one of these problems on using a calculator, if you have pi as any part of the problem, that means that you got to be in radians. So you have to change your mode. If you have degrees, then make sure it's in degrees. Does that make sense? Okay, so the y-axis, you're going to go between -1 and +1. That's what we're going to deal with. Okay? So I know you all have that unit circle somewhere around you. So at least one of you has it out. It's going to be real good. Ready? So we're going to graph sine x. So at 0, remember sine is what value? Y value. So at 0, what's the y value? Is it 1 comma 0, right? At pi halves or 90 degrees, what's the y value? 0. And then what's this one? -1. And then what's this one? 0. Okay. So this oscillates between +1, -1. It becomes a wave function. Okay. So I plot 0 pi at 0, 0. I do have to say that it goes up to 1. It goes down to -1. At pi halves, it goes up to 1. Pi goes back down to 0. 3 pi over 2 goes to -1. At 2 pi. So my sine graph does this. Oh man, it was uh-oh. Tried to make it nice. That's what my sine graph does. It continues doing the wave all the way that way. It continues doing the wave all the way that way. Okay, that's what the sine function looks like. Cosine is going to look very similar to that. We'll do it the same way, and cosine is actually something we'll probably finish this on Friday next week, and we'll start cosine next week as well. So now I'm like doing half lessons, but I wasn't trying to mess things up, but we're like 19 sections ahead of everybody else, so we're okay if we slowed it down to half speed. Some of you might start sleeping better at night. It's like, oh, thank God. It's like my friend Ruben's in the other class, and they're just still dealing with a number line. So what class are they in? All right, so things that we should know is I have y equals a sine of bx plus c plus d is basically our basic function. Now, the a, b, c, and d represent something. Okay? So the first thing we want to look at is the midline, and the midline goes with our d value. Okay? So what line does this appear that it's going above and below the same distance? 0. So we have a midline on this one of 0. The amplitude is how tall above the midline do we appear to be going on this problem? How tall above the midline do we appear to go vertically? 2. So the amplitude is A, and that's going to be 2. Then the period, well, I can tell you this is 0, this is pi halves, this is pi, 3 pi over 2, and 2 pi. So it starts here, and it restarts itself here. So notice it's at the midline going up, at the midline going up. This is at the midline going down. Okay? So our period on this one is just going to be 2 pi. And then our equation, let's figure out this equation. So there's a few things that we need to know. This is our normal period between 0 and 2 pi. That's kind of carries into this region here. Okay, and this region here actually breaks into look like this. Okay, now let me explain what in the world that I just did. Okay? So this is really a sine of parentheses b parentheses x plus c over b parentheses parentheses. Because this is going to do something. This is going to tell us how it shifts right or left. This is going to talk about a period right here. Well, this graph hasn't shifted right or left at all, so I don't really need to worry about that too much. So the values that I definitely know for this problem are, excuse me, here, let's do it. I'll write it in and see if I can explain it from there. Y equals 2, because our amplitude is 2. Sine, so this is one iteration. That's the normal. So I don't have to show anything happening with this. So this is just basically sine of x. Yes, I could put it in parentheses, but I don't have to because it's not shifting right or left. And being that 2 pi is our normal distance all the way around the unit circle. And then our midline happens to be 0. So then my answer to this is y equals sine of x, or y equals 2 sine of x. That is the equation to that line. The 2 refers to that it goes twice as high. If it went up to 5, you would have 5 sine of x. The reason I have it as plus 0 and then I get rid of it is its midline happens to be 0. If our midline changed, then that we would have something like plus something outside of the parentheses after sine. Can I move on? Okay, so this one, they're a little cruel here. I'm okay that the midline is 0. The amplitude looks like it goes 1 above, 1 below. But now we're in trouble because this isn't as friendly as I wanted it to be. So let's see. Here to here, that would be half of an iteration, right? This would be 3/4 of an iteration. Does that make sense? And so this would be 4/4. So one whole iteration would take place there, right? Makes sense how I just said that? So I have one, 2, 3. I have 4 parts of this that are taking place. Increasing, decreasing, decreasing, increasing. Okay, so it starts here, stops here. So notice where this dot is. This dot isn't like in a real friendly, let's be friends kind of place. It looks like if this is pi halves and this is pi, hang on for a second. How often does sine, when does sine start repeating normally? Between 0 and what? It's on the last graph. 2 pi. This is pi right here. Notice this. Start 1, I got 1 and a half at pi. 1 and a half at pi. So 1 and a half plus 1 and a half is 3. Ooh. Hang on, does that make sense? Hang on, let me try and make sense of that. I'm trying to fudge the system a little bit and just use a little logic on it. Okay. Let me talk one more time through that. So start here. I gotta have this in my hand because so we start here and it starts over here. Agreed? But I can't really see. I know that's 0, which I'm happy with, but I'm not quite sure where that is. But I know that half more of this, of our graph, gets to pi right here. Okay? So I have 1 1/2 iterations of my graph from 0 to pi. Normally it takes place from 0 to 2 pi. So if it goes 1 1/2 iterations between 0 and pi, From pi to 2 pi, it's going to do 1.5 iterations. 1.5 plus 1.5, which is 3 halves plus 3 halves, is 6 halves. 6 halves is 3. Ooh, it happens 3 times between 0 and 2 pi. So that graph would go up and down, up, start in the middle, up, down, to middle, 3 times between 0 and 2 pi. Oh, dude, I think I got this. So the period takes place, that happens 3 times. That point here has to be pi thirds. So my period happens at pi thirds. Okay, that's when it starts repeating. Okay, does that make sense how I just did that? I mean, that's like a stretch, but hopefully it makes sense. This is actually like the least one that you would ever see on a quiz. If you take like calculus classes, then it gets a little goofy, but I have other ways to show you on this. So my equation is y equals, my amplitude's 1, so I get 1 sine. How many times did I say this was going to happen between 0 and 2 pi? 3 times. And then my center line, my midline is this. You can clean this equation up a little bit. You don't necessarily have to have the 1 and the 0 put in there. You can just write this. So what this means is it does this 3 times between 0 and 2 pi, which is our normal cycle. Those of you who are musicians, if the sine curve was a musical note and then it happened 3 more times, it's a higher paced frequency, a higher note. It goes from, here's a bad thing, it goes from ah to ah. It happens faster. There's my singing for you. Sorry to subject you to that. Okay, that's kind of a tougher, there's like a lot of critical thinking that takes place with this. Don't panic if you're not seeing this iteration right away. I just want to know, if I say, can you find the midline? Does everyone feel comfortable with that? And in order to find the amplitude, do you feel pretty much totally comfortable with that? The period is yet to be seen. Okay, and I have one more I want to try real quick. Okay, what's my midline here? -3. Everyone feel comfortable with that? How far is this distance right here? 1. My period goes from here so it goes from here to here. Oh, takes place. It happens once there. Oh, this is great. My equation, y equals 1 sine x minus 3. So you could clean it up and just have y equals sine x minus 3. So next time, friends, we have a quiz. You can use that unit circle I gave you on the quiz. Make sure you have a picture of it because I know you remember your phones. Got it? If you forget to bring the picture, make sure your friend has a picture on their phone and they'll send it to you. Deal? Okay. And then I want you to start on, what letter did I get? Are we on? We are on G. Start the G homework. Just start it. You're not going to get done with it. You're okay. We'll go over that a little bit more on Monday. Hopefully we finish it on Monday. But that is all I have for you, my friends. Have a great